completing a square. So last lesson we were looking at a very, very quick way to multiply out square brackets. We're going to use that in reverse to take some quadratic expressions with x square, an x term and a numbering, and write them in a very, very specific way, which is called completing a square. Why are we doing this? Well, first of all, there's two main reasons. One is that this can be used when we look at the graphs of these, and that'll be a later topic in National 5, which will be part of the course. And also, it's used to solve many more quadratic equations that can't be done by factorising. And how to do that is actually not in the National 5 course, but there's going to be an extension video that will appear after this one, which will show you how to do that. I'm not going to focus on the proof here. I'm going to maybe post a link to a proof below if you want to check that out. I'm just going to focus on exactly how do you take this and get the answer we want. And we're going to focus on a step-by-step, fairly mechanical process. So first thing is, we need our x squared first, we need our x term second, and our number last, and we need to make sure that there is nothing in front of our x squared terms. We can't have it as 2x squared or 3x squared, and we can't have it as minus x squared. So let's begin. First thing we're going to do is we're going to open up a bracket. Now x squared is going to drop in power to become an ordinary x, from x squared to an x. The sign's going to stay the same. Now this 6x is going to drop in power, so instead of being an x term, it's going to lose that x and just become a number. So we're thinking it's just going to become a 6. We also need to half it, so it becomes a 3. Close your bracket off, and that bracket is going to be squared. So this plus 2 is still sitting here like this, and the final thing we need to do is we need to look inside our bracket. We need to look at this number here, the 3. We need to square it. 3 squared is 9, and we need to take it away on the end. The reason for this is discussed in the proof. So finally, we're just going to neaten this up. So I've got x plus 3 squared plus 2 minus 9, well that just equals minus 7, and that's my answer. So let's try and repeat the process here. Again, very mechanical. We're going to check that there's nothing in front of the x squared. We're going to check that it's in order, x squared, x term, number. And now we're going to open up a bracket. X squared becomes an x, minus 8x loses the x to become 8, and we half it to make it 4. Close your bracket and write squared there. Don't forget to write that squared in there. Plus 30 is still sat here. And finally, we square this 4, which becomes 16. Doesn't matter if it's negative, when we square it, it's going to become positive, and we always take away there. So when it was plus 3, we square it and take away. When it's minus 4, we square it and we still take away. So that gives me x minus 4 squared plus 30 minus 16, that's plus 14. And there we go. Both of these expressions I've now written in completed the square form. Okay, 2 more examples. And each of these has got a slight twist in them. Well, if you have a look at this one, you might spot what the first issue is. So we've got single x squared, that's great. We've got it in order. However, this 3x is going to be a problem. Let's have a look at why. We're going to open up a bracket. X squared is just going to become an x plus 3x is going to lose the x, so it's now a 3. We need to half it. Now the way to do this is not to write 1.5 or 1.5. The way to do this is write it 3 over 2, 3 halved. And we're going to put plus 2 here. Now the tricky question is, what am I going to take away here? Well, for that, I'm going to go a wee bit of space down here. I'm going to work out what 3 over 2 squared is. So 3 over 2 squared means 3 over 2 times by 3 over 2. And that's going to give me 3 times 3 is 9, 2 times 2 is 4. So I'm going to take away 9 over 4. Still not quite done with the trickiness. What we need to do now is, this bracket is perfectly okay as it is. We can leave that as 3 over 2. Now we need to do 2 take away 9 over 4. The way we're going to do that is we're going to write number 2 as a fraction out of 4. And if we have a think about it, 8 over 4 is the same as 2. And the reason we're going to write it like that is now we can just do an ordinary fractional takeaway. Both over 4, so we're just going to do 8 take away 9 is minus 1. So we're left with x plus 3 over 2 squared, take away 1 over 4, and that's our answer. Okay, this one over here. So again, we've got a slight issue here. The issue here is, well, we've still got a single x squared term. That's good, but it's not in order anymore. So quite simply, we're just going to take it. I'm going to put the x squared term first. I'm going to put minus 2x next, and plus 6 there. And now we are going to just do as normal. Equals, open up a bracket, x squared becomes x. Minus 2x becomes, well, we drop the x, becomes minus 2. Half it becomes minus 1. Close the bracket, remember that squared here. Plus 6. Now minus 1 squared is 1. So we're going to take 1 away, leaving us with x minus 1 squared plus 5. There we go.